Hello, 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 hello. Good afternoon. Good afternoon. It's a Sunday. It's a Sunday. We're back together again. The third of the four-part series, a series that aims to bridge our understanding of how science might shape our future, how we can use these predicted futures to shape the present, and how do we ensure that decisions and discussions include the voices of the African youth. And that is why we are here with you every Sunday. This is the third Sunday we're doing this. So if you're out there listening to us, remember, I want you to invite your nephews and nieces, your neighbors, your friends, your sisters and brothers, grandmothers, everyone, even your primary school teachers. Tell them we're here. What we're talking about affects them too. And if you're 30 or below, then there's even more for you because you have a competition that I'll tell you about later. And so it's good that you hang around because this session, if you listen to it and you listen to the rest of them, the two that went past and the one that's coming next week, and respond to the challenge that we put to you, then you stand a chance to win an all expenses paid trip to Geneva. But why is it critical to include the voices of African youth in shaping the science of the future? Because they can start working now to mitigate both emerging and long-standing inequalities. Only by bringing diverse voices and ideas to the discussion, we can ensure we get the best thinking from every part of our society and corner of the world. We need the fresh perspectives. We need fresh perspectives in these dialogues and debates. It's a matter of intergenerational justice because they will inherit the future. They must be involved in shaping how science should be used to affect it. The partnership between GESDA and UCT to create the Youth Anticipation Initiative through these critical thought-provoking conversations is part of a vision for UCT to ensure that we are a future-oriented university that creates leaders who tackle social challenges. African universities play a critical role in training and upskilling future leaders to be bilingual in both science and diplomacy for addressing global challenges. I can hear you ask, what is GESDA? If you haven't been with us for the last 2 weeks, well, GESDA is a Geneva-based think and do tank. Its mission is to anticipate, accelerate, and translate into concrete actions the use of emerging science-driven topics. Using, among other tools, the GESDA Science Breakthrough Radar, they aim to anticipate scientific breakthroughs and to ensure that we use the predicted advances to improve well-being and promote inclusive development. Today, this afternoon, I'm talking to three amazing scientists, Dr. Adriana Mare, Dr. Chris Trizos, and Dr. Romaric Oriolami. During this session, we will announce the challenge, as I said, and we'll invite you to submit ideas about how you can use the future to shape our present based on any of the topics that we cover in these sessions. As I said, this is the third of the 4 sessions. You will be asked to submit your ideas in early August. For details on the length of the submission, due date, and where to submit, make sure not to miss the sessions. The prize is an all expenses paid trip to attend the GESDA Summit 2022, a global summit of thought leaders on these topics that will take place in Geneva, Switzerland from the 12th to the 14th of October 2022. The summit will bring together academics, politicians, diplomats, executives, and investors from around the world to participate in a series of plenary and parallel sessions of rich and engaged discussions. So we're delighted to have you with us. If you're joining us on social media, please give your comments, write your questions in the comment line. Tell us what you think, and remember to use the hashtag Youth in Science, hashtag Science for Africa, and remember to tag at UCT_news and at GESDA Global. Tag us so that we can see what you're saying. Put your questions and we'll pick them up and I'll ask them to our panel of experts so that they can respond to you. We start with 2 videos on today's theme, and they will play back to back, and thereafter we'll get back to talking to our 3 experts that we invited today. Welcome. Welcome back, welcome back, welcome back. Well, the planet is experiencing unprecedented extreme climate events as we speak. Heat waves, wildfires in Europe and North America, drought in Somalia, and the recent heavy rainfall in KZN that led to flooding and loss of life. Not only loss of life, but also loss of property in Durban and its surrounds. However, with pledges to reduce greenhouse gas emissions by government and business that make it unlikely for us to meet or even be close to keeping below the 1.5 degree heating agreed by governments at Paris in 2015, ensuring the habitability of the planet seems ever more unlikely. Our continent, Africa, will be affected severely by global heating, given its lack of resources to mitigate and adapt to climate change. So, can we engineer our way out of the crisis? Alongside a transition to fossil fuel-free energy resources, such as renewables, geoengineering, let me say that again. Alongside a transition to fossil fuel-free energy sources, such as renewables, geoengineering has been suggested as an additional solution. Geoengineering refers to the deliberate large-scale manipulation of an environmental process that affects the Earth's climate in an attempt to counteract the effects of global warming. And geoengineering aims to remove the greenhouse gases already emitted from the atmosphere, or to offset the effects of greenhouse gas warming by reducing greenhouse gas warming by reducing the amount of sunlight warming the Earth in the first place. And beyond the immediate environment of our planet lies a vast unexplored set of possibilities and unlimited resources in space. Our ability to study Earth from space has changed our understanding of the planet and the way we are altering it. Nations and corporations are only just beginning to explore the potential of space resources, whether that is through asteroids mining or programs for long-term human habitation beyond Earth. And now we have Dr. Adriana Morea, and Adriana is going to help us answer some of these questions. Adriana, thank you so much for making time to join us. Let me tell people a little bit about yourself. Adriana is a theoretical physicist. She's a technologist, an internationally renowned advocate for off-world exploration. Her PhD and postdoctoral work in theoretical physics was in the field of quantum biology, focusing on photosynthesis and origins of the building blocks of life in space. Adriana is currently a director at the Foundation for Space Development Africa, scientific moderator on space resources with the Geneva Science and Diplomacy Anticipator, and chair of space sciences, TODAS, aeronautics and space research. She's also faculty at the Singularity University and Duke Corporate Education. In 2019, Adriana founded Proudly Human, and she's currently leading the organization's Off-World project in preparation for extreme conditions on Earth and beyond. Adriana, please introduce your views briefly on how the future of space resources could be used to change the present.
Thanks, Prof Mamokgethi. It's a great pleasure to be here with all of you this afternoon. And no pressure, because usually I define space resources as everything except Earth, but in this session we're also going to include Earth, so brace yourself for the ride. That will be our discussion today, some really important topics. So when we say space, a lot of people get a vague look in their eye and think that space doesn't directly impact their everyday life. So firstly, let me start by reminding us that we are in space. Okay, we are traveling around the sun at around 100,000 kilometers an hour. If it's still daytime wherever you are, we can thank the sun for that, which is of course sending its light and heat through space to our planet. And that's pretty much the primary space resource and source of all energy for life on Earth, namely the sun. So the second most important source is water. About life, and in fact much of the water on our planet was delivered from space by asteroids and comets. So power and water are most fundamentally in fact space resources, and I'll return to that as a theme as we go forward. But since I've mentioned comets and asteroids, let me actually start off with the furthest kind of realm that we are thinking about when we're thinking about space resources, and then I'm going to make my way in a few minutes. So we don't have the technology currently to leave the solar system, so although space resources theoretically includes the whole universe, let's limit ourselves to the solar system for now. So the asteroid belt, where the majority of asteroids sit, is between Mars and Jupiter. And in fact, these rocky bodies that orbit the sun but are too small to be categorized as planets are a source, a very interesting one, of metals and minerals and water and all of the other, resources that we would find here on Earth, perhaps with the exception of life. So let me draw the parallel with the kind of minerals and metals that many are talking about in the asteroid belt and with traditional mining here on Earth, because maybe you've heard of asteroid mining. Maybe you've heard that the estimated value of the asteroid belt could be 700 gazillion, I think was the word used. There's about 18 zeros in the number that is the value of the potential resources that we could bring back from the asteroid belt. So what relation does this have to terrestrial mining? And let me bring it back to Africa and to South Africa. So not many people may be aware that the largest known impact crater on planet Earth is the Vredefort Dome. This is around 160 kilometers wide, and it is thought to be the biggest impact site of an asteroid around 15 kilometers wide that hit our planet right near Johannesburg around 2 billion years ago. So the largest deposit of gold ever found on Earth, we should know as South Africans, is in the Witwatersrand region. So in fact, there is correlation between places on Earth that have been hit by asteroids, firstly because asteroids do contain a lot of metals and minerals, but secondly because of the disruption to Earth's surface that they can cause the metals and minerals that are nearer to the Earth's core to rise up to the surface. So for the entrepreneurs out there who are thinking we should look for impact sites, then we can mine there. This has largely already been done. So for me, the motivation to look to the asteroid belt for a source of minerals and metals plays in perhaps to the rest of the conversation, namely that we cannot continue to harvest resources from Earth in the way that we have been doing. And mining is one of the ways in which we are contributing towards the disruption of ecosystems. So as Africans, can we sit together and say, eco-regeneration is more important to us than digging 4-kilometer deep holes in places where people and other species already live? That's the depth of the Mponeng mine at the moment. And the amount of gold that's coming out of these mines is, of course, nowhere near what it was like 100 years ago. So as Africans, let's sit together and think, can we be a part of the plans to harvest our really critical, let's be honest, metals and minerals for all of the technologies we're using to hold today's session amongst all of our other daily activities? Can we contribute to thinking about a future where we don't dig up the surface of our beautiful planet that's teeming with life, but rather, or the oceans, which is of course the next thing on the cards, but rather think about extracting our resources from the asteroid belt, because many of these asteroids are in fact the cause of planetesimals. The metals and minerals are waiting there. We don't have to dig to get them out. Okay, that was the asteroid story, which I found really interesting. And in another couple of minutes, I'm going to include the rest of our space resources, so we have time for everyone else. So I'm gonna skip the discussion on living on Mars for now, because maybe you have heard me talking about that before. But let me skip to the moon, because that's happening in the next couple of years, right? Our return to the moon. So as disappointed as some of us may have been to have missed the Apollo era, we are finally going back to the moon, like more than 50 years later. But this time we're going to be thinking about those critical resources that I mentioned in the beginning, and that's like power and water, obviously critical for human settlements wherever we're going to be, whether that's in the Sahara Desert, in an informal settlement, in a refugee camp, or between a community of people living in the middle of nowhere on the moon. And the kinds of technologies we're going to need, namely hydrogen fuel cells, perhaps nuclear, solar energy. Then we're going to move on to water, so extracting hydrogen for fuel from water, extracting oxygen to breathe from water, and of course recycling wastewater with high efficiencies and high-tech solutions. This is the kind of thinking we're going to need to establish a human settlement on the moon. And there are many parallels between these exact technologies and the kind of thinking we need here on Earth to better extract energy, whether it's from the sun or from other chemicals in fuel cells. But we know we are moving away from fossil fuels, and the challenge of producing power in space has many parallels with the kind of direction we need to think about here on Earth. And now finally, let me move to the area of space resources that perhaps we are the most familiar with, and that's low Earth orbit. So in Earth orbit, also geostationary orbit, which is further out, we've got thousands of satellites. In fact, the very word globalism potentially can only be possible because of these beautiful images that we have of our planet from space. And these are made possible by satellites. So we use satellite technology every day. Every time you swipe a card, every time you navigate somewhere, satellites are bouncing signals off each other to create the global payment network and to enable GPS, which we find so indispensable wherever we find ourselves on the planet. Also, of course, data that comes from satellites, I'm sure, is going to play a role in the upcoming discussion to monitor large-scale activities on the surface of the Earth, whether that's deforestation or weather patterns, or just general monitoring of human activities on the surface of the Earth, which of course we know are contributing towards the crisis of climate change that's coming up. So let me conclude by saying technology is a tool. It's how we use it that's critical. And I think the most important lesson we've looked from exploring the solar system is that Earth is the only planet that we know of that hosts life. So abundant with life is Earth that we can see it from space in the form of the photosynthetic belts that cover a lot of the planet. And our priority for using any technology, I believe, should be out of respect for life, out of respect for our fellow humans, and out of respect for all of the species that we share this planet with. And if we are going to explore space, which we are, and that's super exciting because we are explorers as humans, I think we need to hold life most precious in these endeavors and think about wastewater management systems, clean fuel production, producing food in small spaces, communication systems. And these are technologies certainly not limited to communities on Mars, but really critical for communities of humans everywhere. And exploring space has given us a lot of innovations towards solving resource management, which is going to be at the heart of a future we can be proud of, whatever planet we're on. So let me leave it at that for now. Thank you very much.
Thank you very much, Adriana. Thank you for your insights. Let me introduce Chris so that we get time for other conversations. Dr. Chris Trizos is director of the Climate Risk Lab at UCT's African Climate and Development Initiative. The lab that Chris leads builds tools to predict when and where climate change risks appear, and how society can respond to climate risks in a way that is rapid, just, and equitable. Chris's research focus is on the intersection of climate change, biodiversity, and human well-being. He's a coordinating lead author for climate change impacts, adaptation, and vulnerability for the Africa region and the Intergovernmental Panel on Climate Change. 6th assessment report, and a member of the co-writing team of the IPCC synthesis report. He has also consulted on climate change risk and adaptation for the World Bank. Before moving to the ACDI at UCT, Chris spent 3 years as a postdoctoral fellow at the National Socio-Environmental Synthesis Center at the University of Maryland, where his research focused on biodiversity, climate change, and geoengineering. He completed his doctorate at Oxford, and he teaches a graduate course on interdisciplinary and actionable science. Chris, can you explain to us the difference between eco-re-engineering and geoengineering, and then give us your brief views on how they can be used to change the present?
Thanks for having me. It's good to be here. Yeah, absolutely. So eco-regeneration, a lot of people refer to it instead as ecosystem restoration. And so a focus there really is on restoring damaged ecosystems or degraded ecosystems. I would say most important before we even think of eco-regeneration in many places is conservation and protection of ecosystems that remain intact. And in an African context, we have large parts of our continent where ecosystems are still relatively healthy compared to many other parts of the world. And so an important first stage is actually caring for and living with and benefiting from in a reciprocal way with the ecosystems that are already there. And so a next step can be ecosystem restoration. And in the context of climate change, something that a lot of people talk about is planting trees. And so that video we were shown earlier had tree planting as one of its examples. I think, again, in an African context, this is something for us to be careful about, right? And that's tree planting is not in a climate change context like a silver bullet solution. A lot of people talk, oh, nature-based solutions, go and plant a tree, solving climate change. And that's really not true. And it is not true. It has difficulties for a couple of reasons. One is many of the places that large international tree planting campaigns identify as suitable for planting trees to offset our greenhouse gas emissions are actually ancient, very rich in biodiversity and culturally important ecosystems in an African context, for example, our savannas and our grasslands. And so if we plant trees across our grasslands because we want to absorb CO2 from the atmosphere and perhaps prevent further climate change, at the same time we're losing a lot of biodiversity, we could be losing a lot of water supplies, we're losing places where people graze livestock for food, and we're also losing places that are really important for ecotourism industry that employ lots of people and jobs right across the continent. And so the message I'd finish with on ecosystem restoration is it's really about doing the right restoration in the right places that respects the local context. And so promises we hear about tree planting are often oversold, but ecosystem restoration is also an important part of the solution. Moving to geoengineering, that is something very different. When many people say geoengineering, what they are talking about is the idea that we could offset some of global warming, so not deal with the direct cause of the problem, which is burning fossil fuels that create greenhouse gases that warm the planet, but instead we could do something that an analogy would be like if you're feeling unwell and you take a painkiller and it treats the symptoms of the problem, but it's not actually solving the root direct cause of your sickness. So geoengineering is something like that. It's saying one technology that Ramarik, who will talk next, studies a lot, is called stratospheric aerosol injection. And this is the idea that we could spray some tiny particles high into the stratosphere, many tons of them. The stratosphere is more than 10 kilometers above the Earth's surface. and they would be distributed around the world in the upper atmosphere and form like a thin veil around the planet and reflect a small percentage of sunlight back to space, and that this could then limit or offset the amount of global warming. If you did a huge amount of it, you could potentially, in theory, even cool the planet. And so some people say that if we continue to delay in cutting greenhouse gas emissions, and it's important to remember here that Africa has contributed a relatively small amount historically and still does to global greenhouse gas emissions. South Africa is an exception. We get a lot of our electricity from coal, so we're actually quite high polluters in South Africa, but as a continent, we've contributed very little. So a lot of mitigation needs to happen in the global north and in China. So the United States, China has major polluters. But some people say if all the countries of the world globally don't act fast enough, this geoengineering technology might be one of the only or the only option we have to keep global warming below 1.5, well, around 1.5 or below 2 degrees Celsius. I'd just like to end by saying that while that might be true, these technologies are not being deployed today. Some people talk about chemtrails, conspiracies, and aeroplanes spraying for geoengineering. That's not happening. Scientists are not geoengineering the planet today. What scientists are doing is studying geoengineering using computer simulations. So they simulate the global climate on supercomputers, and then they simulate a geoengineering intervention, the releasing of particles into the atmosphere in the computer simulation, and they see what it could do to the climate. And from that, we have a pretty good idea that it could stabilize warming or even cool the planet. But the technologies for whether this would actually work, if we decided to do it in real life, are not developed. There would be a huge amount of research required for that. And also, we have very little understanding of it, if it would actually reduce the risks to people and ecosystems. So, for example, it might reduce extreme heat, which could reduce heat waves, which would be a good thing for human health. But other research shows that it could also shift the geography of where malaria is transmitted on the planet by shifting the climate suitable for the malaria mosquito. And so some research we've done suggests that up to 1 billion people could be like the difference between the lowland tropics. If you did geoengineering, it would cool the lowland tropics, areas like Nigeria, parts of lowland West Africa, and actually make them more suitable for malaria than climate change with no geoengineering. And so and that could change the risk of malaria for about 1 billion people globally across South America, Africa, and Asia. And so the last thing to remember with geoengineering is there is this very high risk that some areas could win and some areas could lose. And that's unlike when we talk about reducing carbon dioxide emissions. By stopping fossil fuels, we can create jobs through renewable energy. We can transition to a healthier atmosphere by not having air pollution. People can live longer lives. There are many benefits to consider from rapidly decarbonizing before we put all of our, I would say it's too risky to bet the planet on geoengineering. We don't know enough about it at this stage. Thanks.
Thanks very much, Chris. Thank you very much for sharing. And that's fascinating. I'm sure we're going to hear more as we go along. Romaric. Let me introduce Dr. Romaric Oduolami. He's a Carnegie Junior Research Fellow at UCT's African Climate and Development Initiative. He aims, through his research, to enhance human development outcomes in the context of climate change. His research interest is around assessing changes in regional climate risks arising from human influence on the climate in Africa. He focuses on quantifying changes in the risk of weather and climate extremes in Africa using the attribution science concept and climate modeling. His current research involves assessing the influence of human-induced warming on climate or weather parameters used in insurance risk modeling and the cost of insurance. His focus is primarily on agricultural insurance in Africa. Other research interests of his include improving knowledge on the possible impact of solar geoengineering on the future climate in Africa. He completed a PhD in meteorology and climate science in 2016 and has a strong background in agricultural sciences. For his PhD research, he used climate models to examine the potential impacts of large-scale forestation on climate extremes over West Africa. Romaric, what can you add to Chris's views? Eco-regeneration and geoengineering, how can they be used to change the present? Can you add anything to what Chris has already said, Romaric?
Thank you for the question. It's really a great pleasure to be here. I'll rather focus mostly on the geoengineering part, which is an area where I have more expertise. And when it comes to geoengineering generally, we have different categories of geoengineering. The first one is what is referred to generally as carbon dioxide removal technologies. As the name indicates, the aim is to remove carbon from the atmosphere, and through different approaches like large-scale reforestation or using more advanced technology to retrieve the carbon directly from the atmosphere. And the other category, which is more well-known approach, is referred to generally as solar radiation management or stratospheric aerosol geoengineering, or even just solar geoengineering. So when it comes to solar geoengineering, the idea of solar geoengineering comes from observation from the nature. So whenever we have a major or a large volcanic eruption, huge amounts of sulfur dioxide are ejected, and those sulfur dioxide, in case of very important volcanic eruption, can reach as high as the stratosphere and constitute that thin barrier of aerosols that can now act as a barrier in terms of reducing the amount, a small amount of the solar radiation that is coming to the Earth's surface. And by doing so, it can contribute to cooling the Earth's surface. So in few cases of major volcanic eruption that has been observed, and scientists thought that maybe we could replicate that by ourselves, especially when it comes to reducing warming. But that will definitely come with a lot of risk. And up to now, we are not capable of understanding fully what could be the risk of solar geoengineering. And especially in developing countries, in Africa in general, but also Southern America and most part of Asia, research into solar geoengineering and the potential impact of it on their climate is not well known. Just recently, research has started in most developing countries, and those research have shown very interesting results in Africa, where we have looked at the impact on drought, or the impact on a Cape Town Day Zero drought, for instance, where we have seen that solar geoengineering can reduce the risk of such drought in the future, etc. And up to now, research in developing countries is very low, and there is need for more research in order to inform Africans, the youth, also policymakers, on what solar geoengineering is and how it can impact us, and what we can do, what we need to know to be involved in a global discussion about solar geoengineering, if there is a need to discuss it. Yeah. So for now, research is still ongoing. We at UCT, we have a research team that is working very hard on the topic and analyzing different aspects of solar geoengineering and how it will affect our climate in Southern Africa and also agricultural production in Southern Africa. So for now, I'll stop there. And if there is any more questions related to that topic, I'm happy to to come in again. Thank you.
Thank you, Romaric. Chris, you are an IPCC author on the climate change impacts and adaptation options in Africa. And one of the key topics identified by GESDA that requires scientific and diplomatic anticipation is solar geoengineering. Controversial approach to limit global warming by blocking the sun and deflecting more sunlight into space. If the world went ahead with this technology, it would be the most global endeavor undertaken by humanity. Can you explain how this technology would work? What are the potential benefits and the risks to our society, to our biodiversity, our food systems, etc.? What governance frameworks do we need to safeguard such risks and find consensus on what level deployment should take place? I mean, this sounds like a very risky endeavor. Even if it brings a solution, the risks are huge. Chris?
I agree it's a very risky endeavor. I think in terms to your earlier question of how can solar geoengineering, this idea that scientists are studying mostly in computer simulations still, how can it influence the present, is an interesting question, because many people are concerned that even just talking a lot about solar geoengineering now, researching it a lot, getting attention from governments, could be a negative thing by taking attention away from reducing fossil fuel emissions. So people call that this moral hazard, that there's some technology in computer simulations that we in theory think could limit global warming. And because of that, people in positions of power in government or large public or private corporations think, okay, geoengineering might save us down the line or will save us down the line, so we don't need to reduce our fossil fuels as fast right now. So that is clearly a big risk. And from the science side, we don't know enough yet about if that would happen in society. There are some social surveys and experiments that suggest it could happen. When they ask, by experiments, I mean they get people in a room and they play a game around climate change actions. And then they say, imagine there's this technology, how would you respond? And some people, as a result, do decrease their investment in reducing greenhouse gases, but other people actually increase it because this technology sounds so scary that they think, wow, if that's the option we're left with, then I want to reduce my greenhouse gas emissions extra fast. And so I think it is too risky still. No one is, well, not many people are suggesting that this should be deployed. Some people are arguing for a non-use agreement by governments globally, that governments should get together and agree that geoengineering could be researched, but it should not be used as part of the solution for climate change. Other people are saying that that restricts knowledge creation too much, and that if we don't get carbon dioxide emissions under control, we may need this as an option in the case of a climate emergency, and so we should still do the research. It is way too early to say if this would benefit people and ecosystems under an actual deployment in the real world. Scientists have studied in computer simulations. People like Romaric have done work on what might it mean for the climate, like Romaric mentioned, the Cape Town drought. But when it comes to what might it actually do to people and to ecosystems, to food systems, to our health, there are very, very few studies, and we don't know nearly enough. And some of the ones that are out there suggest that there could be big risks. For example, if we had geoengineering on and it's offsetting the global warming, but we're not also reducing our greenhouse gases, right? Like the analogy I gave earlier, it's like taking a painkiller. Then if something went wrong and we switched it off, suddenly all that warming from the greenhouse gases that we've been covering up with the geoengineering would come back very quickly, like within a decade. And so that rapid, people call it the termination shock, this rapid shock to the planet that would come from a geoengineering failure if you hadn't also decarbonized, could cause thousands of species to go extinct because you'd get such rapid climate change within a decade. So there are a lot of big risks here that we are only beginning to understand. I think it is important, though, that governments are aware of these technologies, especially African governments and scientists in Africa, because global conversations about it are going to happen. They're already starting. And as African scientists and policymakers and communities, people need to be informed so that our views on these technologies can be part of that global conversation. And it's not just that other powerful countries set the research agenda, but we can have an African voice in what we think important research questions are on these technologies. Thanks.
Thanks. Romaric, I mean, as Chris says, you have studied the potential effects and impacts of solar geoengineering in Africa. What is the status and level of preparedness of developing economies, especially in Africa, in adopting geoengineering policies and practices? And then could they deepen climate injustice and inequality and exacerbate geopolitical tensions? Romaric?
Yeah, so of course, we did a couple of studies on the impact of solar geoengineering on the climate in Africa in general. But of course, they can, in terms of preparedness, I think African developing economy in general, including Africa, are quite late in terms of what could be the impact of solar geoengineering on their climate, on their economy, etc. Because there are until 2020, there have been no research which was exclusively Africa focused, led by African researchers on the impact of solar geoengineering on the climate in Africa. So the very first research was published here with a team of researchers here from UCT I was part of. And that research focused on the whole continent and tried to give us some insight on the potential impact on temperature and precipitation. And one of the major findings is that while SRM, solar geoengineering, tend to decrease temperature over the whole continent, the impact on precipitation was very spatially heterogeneous. So it varied from a region to another. It might decrease it in one place and increase it in another place. Another research we did was to take the Cape Town drought, 2017-2015 day zero drought, and put it in the context of a geoengineered climate and see what could happen in the future. And we got some very interesting research there that were very encouraging. That shows that, solar geoengineering, a future with solar geoengineering compared to a future without solar geoengineering means 90% decrease in the risk of day zero drought. So those research is very important, but at the same time, we need to understand that we cannot just take the research, that positive result in terms of the impact of SRM on the Cape Town drought, which is just a small region over the whole continent, even globally, and think that solar geoengineering is good. We need to do it just because Cape Town might benefit from it a bit. No, because in other parts of South Africa, for instance, it might increase flood. For instance, in KZN, it might increase flood, or in other places, it might increase drought, etc. So it's important to analyze that from to go deeper and to be more specific in terms of the findings in order to better inform African communities and generally developing countries on the potential impact solar geoengineering could have on them. And that will increase their preparedness in terms of their awareness of the technology, its potential, and get them ready in terms of negotiation when it comes to climate negotiation. So in terms of deepening climate injustice and inequality and geopolitical tensions, solar geoengineering, the way it is designed or the way it can be designed, can only be a global intervention. As we all know, up there in the atmosphere, there is no boundary. Yeah, countries can say, "Oh, you are in my airspace," etc. But that doesn't mean you might have your airspace, yes, but that doesn't mean when a country like China or the US is emitting CO2, the CO2 will just stay over China or over the United States. No, it might spread all over. And And at the end of the day, it will affect us all. So we need a global, it can only be a global intervention. If a country decide to go for it, it may do it, but it will have a global impact. A very simple example is in the case of volcanic eruption. Volcanic eruption generally happen locally, but depending on their intensity or how big they are, they can have global impact. And so, of course, there will be injustice. And one of the first injustice is the gap of knowledge between developing countries and developed countries, where the developed countries are quite advanced in terms of knowledge on the impact of solar geoengineering. The developing countries are quite backward. And if that continues, whenever there will be discussion, the discussion can only be into one direction. The developed one telling the developing what to do or what to decide. And we don't want that. That's why research is necessary in order to help prepare activists, policymakers, and governments across the developing country to be more aware of the topic and to know what could be the impact on their region and countries. And a very good way for the African youth to be involved in solar geoengineering is through research. Research is a very first step. Research to inform, to get informed about it, to better know about it. Not that all the African youth need to come into research, but at least they can find out about research that has been done in order to improve their knowledge of the topic and use that now in their other activities like activism, or depending on where they are, where they work. If they are working in government, they can use it to influence governmental decisions, etc. So those are very important things I think young Africans can do to improve their knowledge of the topic, improve their knowledge of the impact of solar geoengineering, what it is, how it works, in order to influence their communities, their countries in improving knowledge about the topic and helping in decision-making when necessary. Thank you.
Thank you very much, Romeric. Let me say thank you to all the people out there who are listening to us. It's a fascinating conversation. I see some really interesting questions. And Adriana, I want to ask you this question, but of course I see another question there that's sort of somewhat related, that has it's related to the question that I wanted to ask you. So, since I mean, you are the director of the Foundation for Space Development Africa, an organization that aims at sending Africa's first mission to the moon. And one can ask, why is it time for Africa to expand its role in space exploration, and how can Africa's youth get involved? But the other issue, of course, is that since humans landed on the moon, our population has doubled, and our use of resources has grown rapidly in quantity and diversity. So while there's a clear scientific motivation for exploring the environment beyond Earth, another reason is to harness the virtually unlimited extraterrestrial resources to fulfill our growing demand. But the 21st century space race will increase competition between world powers. What are the legal and geopolitical concerns raised by the use of space resources? And how should we govern our activities in space to ensure benefits for all humanity? Adriana.
That's a great question, and probably the topic of several PhDs. So if anyone found that as interesting as I did, yeah, that's a deep question. My challenge is to try to answer it. So Yeah, regulations in space. I mean, let's start there. And the Outer Space Treaty was drawn up in the 60s in anticipation of the landing on the moon, the Apollo era of 69 to 72. Excuse the parrot in the background. And we have largely not updated a lot of this law. So for any young people out there interested in legal aspects, space law is a really important topic that we need to do more work on. Treaties govern the behavior of countries in space, and signatories of those treaties then govern the behavior of companies increasingly nowadays and government entities that are launching from that country. So if, for example, you're in a country that hasn't signed a particular treaty, in effect, you can behave as you like. And there are examples of countries like North Korea, for example, that may not be part of these treaties. So that's one aspect. Another aspect of legislation is look at low Earth orbit. Look at Earth orbit. It is full of debris, and the risk of catastrophic collisions with either space stations or between major communications satellites is increasing, as on the one hand we are super excited to launch a lot of satellites that can enable communications in places that may not have access to ground-based communication systems. Think about SpaceX's Starlink. Now SpaceX has launched thousands of satellites to make connectivity for people in Tonga after the volcanic eruption, where their cable, their undersea cable was disrupted, able to access, critical communications in a time of emergency. I see Mozambique and Nigeria have already been approved for the rolling out of Starlink receivers on the ground with the SpaceX fleet. So I wonder when South Africa will join that party, because then for a relatively low fee compared to other satellite links, you can have 50 megs per second download speeds at any location on the planet. So this is beautiful. But the sheer number of satellites that are now in orbit creates this debris problem, as I've mentioned. There are hundreds of tons of highly sophisticated electronics and other parts of debris which are defunct satellites, remnants of various space missions that haven't been cleaned up, all in orbit around our planet. And that actually brings me back to the discussion we've had now about geoengineering, and thinking when we start putting bigger things than satellites, like large arrays to bounce sunlight backwards, or whether we're doing solar absorption in space or whatever we may be doing, the larger the structures we put out there, the bigger this problem's going to get. When are we going to draw up clear regulations on who's responsible for cleaning up this mess? Because we know humans are good at creating a lot of waste, but what we are not good at is recycling or repurposing or removing this waste. So here's another great avenue for people entrepreneurial minded who are interested in space, besides the asteroid idea. And that's, how can we repurpose space debris to build stuff in space? And people are thinking about this, but not enough. There's hundreds of tons of metals and other things in orbit. So in theory, we can build several space stations with this exact material that's already in space. I could go on about this for hours, but I think space law, super exciting. Entrepreneurial repurposing of space debris, super exciting. And we didn't even get to the idea of the moon, but space is happening. And Africa needs to participate, because debating about whether we shouldn't get involved or whether we can get involved is too late. At this point, we need to generate excitement, generate interest, and get involved, because the humanities space program is going ahead with or without us. So it's time for us to forge our involvement in these programs while we're on the brink of expanding our society beyond Earth.
Thanks, Adrian. Chris, I'm going to do one round of questions here. I know that we said we end at 5, but I'm just taking liberty to do one more round. I hope you can be available. Chris, here's a question from online, that the futuristic solutions, the person says the futuristic solutions being looked at sound incredible, but don't we first off still need to look at reducing human population numbers? Isn't this the root cause, Chris, that you were talking about?
So this is a question that comes up a lot. And yes, in some cases, population growth can be a risk factor for human use of and overuse of the environment. But in that word, overuse is another large part of the problem that, at least as far as we're talking about climate change, is the major part of the problem. And that is, when you look at greenhouse gas emissions that cause climate change, the strongest correlator with that is not the number of people in a country, it's levels of unsustainable economic development and economic growth. So, for example, there's a lot of overconsumption of resources by people in relatively wealthy countries. People in most parts of Africa, most parts of India, most parts of China, that on average, the per capita contribution to greenhouse gas emissions is much, much less than people in the United States or in Europe. And it's not just between countries. For example, the wealthy in South Africa, the relatively wealthy, have a much higher environmental impact than low-income people in South Africa. And so a huge part of the solution before we start talking about, oh, the problem's population growth and we need these technological solutions, is really to look at our patterns of consumption. And Adrian has been arguing and putting forward really good solutions potentially around space exploration. But before we even get there, there are really useful concepts about how do we control our demand on Earth. And the IPCC, the Intergovernmental Panel on Climate Change, which is the major global body that every 7 years summarizes all the research on climate risks and solutions, is very clear in its most recent reports that a big part of the solution for climate change is changing consumption patterns. For example, people in many wealthy countries eating more balanced diets. So that's eating relatively less meat and more vegetables, switching from driving in individual cars to using public transport or cycling, changing energy efficiency in homes. And so just to finish on that population growth is often the wrong target. And what we should be looking at is how we actually reduce our consumption and consume more efficiently.
Thanks, Chris. Adriana, does Africa have the means to make the most of the use of space resources that you describe? Is this not another area where we could be left behind while rich nations speed ahead with technology?
To answer that briefly, let me tell a funny story. So when I was doing those career survey questionnaires in matric, the final year of school, then my major recommendation that came out of that was to be the manager of a sewage plant. So I was kind of horrified at the time, to be honest. I said, really? Is this... However, nowadays I find myself thinking a lot about managing wastewater in space. On the surface of Mars, for example, the role of microbes in this process, how we can extract fertilizers from organic waste, how we can extract nitrogen as a fertilizer, how we can extract hydrogen for hydrogen fuel cells, for example, and of course to get clean water out at the end of that. Now, my point here being that the kinds of solutions that we are going to arrive at for extreme environments like the space station or the moon or Mars or wherever in the solar system people might want to go are, in fact, and luckily for us, the same kinds of solutions that we need to come up with here, whether we're thinking about overcrowded cities or informal settlements, to have really efficient, low-cost, robust technologies that can manage our waste, manage our resources basically highly efficiently, I think is the primary celebration of space exploration, is this endeavor to become more resource efficient. You know, our use of solar technology now to mitigate the climate crisis arguably developed from space exploration. You know, we were using solar powered technology in space way before we were thinking about the dangers of burning too much fossil fuel. We were using newly developed membrane technology to manage wastewater in the space station, you know, arguably before we started thinking on a large scale about managing our wastewater more efficiently here on Earth. So exploration drives innovation, I believe, because when you get out of your comfort zone, you think about new ways of doing things. And so I think the parallels between the kinds of developments that need to happen on the ground in Africa, you know, growing food in really small spaces to cater for a growing urban population. There are massive parallels between all of these things, power systems, water systems, food systems, and communication systems, between being on the ground and between being in extreme places in space. So I hope that some of these topics that we've talked about here get people excited about becoming managers of sewage plants, for example, because we can do both. we can uplift communities and empower people living on Earth without access to basic resources at the same time as we think about developing highly sophisticated settlements and villages in space. And what a grand future that would be if we could have people living, whether on the moon or Mars or someplace in Africa, using the same kind of technologies and really celebrating what it is to be human, which is to use technologies to improve standards of living and also to explore space at the same time. We can do both, and I think that's the challenge for Africa, is to get young people excited about exploring, excited about learning, perhaps physically exploring, but more importantly, I think exploring new ways of doing things, whether it's here or on Earth or among the stars, which hopefully will be our future.
Thanks, Adriana. Romaric, I want us to go towards the end, and I want you to give us your closing remarks. And as you do that, sort of think with us about the implications for the African context and the role that African youth can play and how should they be involved. You know, if I'm there sitting somewhere in Benin and manage to catch this, and I'm looking at this, and and I'm saying I want to get involved, how can they be involved? As you wrap this up, Romaric.
Thank you. I think developing countries, and particularly African countries, are the most at risk when it comes to climate change impact. And they are also the one who will benefit the most or lose the most when it comes to solar geoengineering. And how possible is it for someone who doesn't know about solar geoengineering can make a decision about it, a decision that is going to affect his life, his everyday life? So it is very important that African communities should be informed, and to be informed in terms of research findings. More research needs to be there, more research needs to be founded, and so that our political policy makers and everyone who are all those who are involved in terms of decision making across the continent should be well informed in terms of solar geoengineering and any other type of any other topic we have discussed today, like eco-regeneration or space resources, because that's the only way for us. The only way for us to be able to make decisions, the only way for us to be involved is to know. We cannot make decisions about something we don't know. Yeah, so I will end up with that sentence. It's impossible for us to make decisions about things we don't know. So we need to improve our knowledge to reduce the gap knowledge between us and others.
Chris, I want to close this. Now, I'm a young teacher somewhere in Nairobi. Just completed, I'm enthusiastic, and I hear that this climate change issue is important. Bumped into this session, and I'm thinking, how do I get my learners involved? How do I get involved myself? I've got all this energy. What would you suggest to me, Chris?
That's a really good question. I think first, if you're on social media, there is a list of climate and environment scientists, which includes a lot of African researchers. That can be a good place to go, to follow, to get local updates. Another thing that you can do is really engage in a growing climate change literacy movement that's starting with some interest from UNESCO, from the United Nations Development Program, where climate change literacy here is understanding what climate change is, that it's caused largely by human activity, and what are the consequences in the places where you live and work. And so one place where you can go and get resources on that is just Wikipedia. It's being updated with the latest IPCC findings over the next couple of months. There are good pages on climate change in Africa. There's a good page on climate change generally. Another thing that's quite a fun way to do it, something our lab has developed, is a game called Survive the Century. I actually have a book here. I didn't know you were going to ask, but it's online. It's called Survive the Century, and you can play through, and it's a game about climate change, and you can play in an interactive way in a classroom. And then I'd say another thing, I could post a link. I'd have to look it up quickly, but there is a fact sheet there are fact sheets on Africa on climate change and solutions, and they're available on a website called the Climate Data Knowledge Network. And these fact sheets are, or just cdkn.org is a good place to go.
If you put it on the chat, because not everybody will get to the chat, I'll put it on my Facebook page
Okay.
with reminding people where to get the whole recording. But that's very useful. So on that web page they'll get resources.
Yep, there are short fact sheets. What does climate change mean for West Africa or Southern Africa or East Africa? And they're also in French for West Africa and Central Africa.
Fantastic, fantastic. Adriana, in closing, I mean, you and I are women, and we know on this continent of ours, many women don't get into science. Now, there's all of this, and you are out there on the cutting edge. Young women want to be like you. What would you say to them in terms of getting involved? What's the first step? How can they get it? How do we excite them?
I hope some of the topics we've talked about here, which is critical at the same time, I think, as being inspiring, because we can't lie to ourselves. This is an uncertain time that we are all living in. And the tools that we use to get out of this era successfully, and by that I mean, creating a future that we can be proud of, whether we're reflecting back on all of those who've come before us or forward on all of those who will come after us, we've got to use these tools wisely. So a message for young women wanting to get involved. I would say it's critical to have the right mentors. And if I reflect back on my career, these were mostly men, given my age and the gender bias that was present at the time. This is changing slowly. It doesn't matter what gender your mentor is. It's got to be someone who respects you, I think, and somebody that you respect. And I think, let me give one piece of advice on that. So choose the right mentor. Choose someone who is doing research in an area you find interesting. Choose someone who you can have a conversation with, because whether you're embarking on a master's or a PhD program, the person who is your supervisor, you're going to spend a lot of time with this person, and they're going to help you to direct your career. So don't underestimate the importance and the choice that you have in choosing this mentor. That's where you can exercise your power, I think, choosing the people that you work with. So don't let only the topic guide you, but also the person. They should support you, and you should have respect for them as well. So, and don't let anyone tell you you can't do it. We've heard the saying, the ones crazy enough to think that they can change the world are the ones who do. So go for it. Your crazy idea might just be the one we need to emerge successfully from this arguably crazy era.
Thank you so much, Adriana. Before I let you go, let me announce that we have a competition. We have a competition that anyone who's below 30 years and below can enter. And I'm hoping that they will slide in the competition slide that you can see there. And we will put it, last week I promised to put it on my Twitter page, but I didn't. I'll do it this week. We'll put it on my Twitter page, all of my social media pages, UCT's media pages, social media pages, you'll get it there with details of the competition. And I'm asking you to register to receive the competition information. So just go onto the page, see what you need to register. You just fill in a little form that says this is who you are, you're interested in participating, and then we'll send you competition information so that you can participate. Who knows, this is about ideas. This is about how you use the science of the future to shape your present. And you've heard our 3 speakers today and the work that they're doing and its importance and also its urgency. I hope you've been as inspired as I've been. So thank you so much for joining us. But more than anything, I want to thank our 3 speakers, Romaric, Adriana, and Chris. Thank you so much for spending your Sunday with us. I know you could have been doing something else, and we chose to invest your time with us. We really appreciate it. And thank you for choosing to do this work. I mean, this work is important, but if there was no one on the continent doing it, we would be left out. We wouldn't even know who to talk to. And here we are. We have young scientists like yourself letting us in. And I really, really appreciate your work and the time that you're putting into it to make sure that society is much more informed. Thank you very much to our audience. Tell your friends, your relatives, and so on. The recording will be on the UCT pages, and you can get access to it. Invite mainly the youth, get them out there to watch the sessions that we've done so far, and we'll be there again next week. Next week's session is our fourth and final one, so please join us. Next week we're talking about science and diplomacy. So you might be thinking, what's diplomacy? Come and join us. Science and diplomacy next week. We'll see you then. Have a good week.